Assalamu alaikum. This is your computer science teacher Sarfawad Akhtar Ansari. Today we discussed the topic representation of sound from the O levels syllabus 2210 and 0478. So how does the system represents the sound in the form of the its native language, which is called binary? So first understand what is a sound wave. So we can see that sound waves are vibrations in the air, and the human ear senses these vibrations. Like we can hear the number of sounds when we go outside of our home, or when we are at a particular place such as parks, school or university, or even a party. So we used to sense these vibrations. It could be in any form. So we interpret these vibrations as a sound. Like it could be the sound of whistle, it could be a sound of guitar, it could be the sound of any musical instrument. So this is the sound that we interpret with the help of the sound waves. So these sound waves consist of three most important factors. One is the frequency, other is the wavelength, and the last one is the amplitude. Because we have already discussed that the sound waves are the vibrations in the air, and we diagnose these vibrations in the particular sound. Like it could be a water drop sound, it could be the rain sound, it could be a whistle sound, it could be any guitar sound, it could be any musical instrument sound, or someone is calling our name, so it is also a sound. So we interpret like this. So the sound waves consist of these three most important factors. So let's try to understand. First factor is the frequency. So what is a frequency? We used to call it sometimes pitch, right? And how can we define frequency? We can say that the number of times per second that a sound pressure wave repeat itself. Like in 1 second, how the sound pressures are being generated. Or in easy words, we can say number of waves produced each second. It means that in 1 second how many number of waves are being produced. How is it possible? We can see a graphical representation of it using high frequency and using low frequency. So in the high frequency you can see how the number of waves are produced in each second, and in the low frequency you can see that how many number of waves are being produced in 1 second. So this is the visual presentation of frequency. Next key factor is the wavelength. And what is the wavelength? We can simply say that it is the size of a wave measured from one peak to the next. So the size of the wave, we can measure it using wavelength. As you can see in the graphical presentation, like this is the wavelength, that how we can measure its peak from one point to the other point. So this is basically the measurement of the wave. It is called the wavelength. Next key factor is the amplitude. And how can we measure the amplitude? So it specifies the loudness of the sound, that how much loud is the sound. So we can measure the sound, like you can see in the amplitude arrow, it going upwards. So it is the height, you can say the height of the sound or the loudness of the sound. So here you can see the height of the sound, it is called amplitude. And the wavelength, you can see the two distances from point A to point B. So this is measured by the wavelength. And the height can be measured by the amplitude, where we can specify the loudness of the sound. This is called amplitude. I hope you understood the point. Now let's see that sound waves, how does it work with the computer system. So sound waves vary continuously, means there is a continuous wave of the sound for the longer duration, or it could be the shorter duration, such as 1 minute sound duration, 5 minute sound duration, 20 minute sound duration, right? And the sound basically is the analog value, and computer does not calculate the analog value. So the sound of any kind is the analog value, and if we want to measure it, then we need a converter. It is called analog to digital converter. And why do we need analog to digital converter? Because if we want to transmit our sound using the computer system, so we need analog to digital converter. So it converts the analog sound into the digital sound using its converting mechanism. Because computer only understand binary language, which is its native language, so it needs to be converted, analog values needs to be converted into the digital format. So this is how our system used to imply these key terms, wavelength, frequency, and all this stuff. So these analog values must be converted into the digital data before it is transmitted to the user. So as you can see in the graph, sound amplitude shows the y-axis and the time interval shows the x-axis. Let's see at the time interval 1. It says the approximate amplitude is 10. Approximate means it could be the 10, it could be the 9. So approximate value is the 10. We need to measure the highest value. So at the time interval, let me use my drawing tool so it is easy to explain you. As you see time interval here, as a time interval, if you see the arrow, time interval is the one, and where it goes to the highest peak. Let me zoom it for you. Here you can see the highest peak is the 10. So let me draw it. Let me increase the thickness so it would be visible for you. So the highest R peak is 10. Let me transparent my shape. So you can see time interval is 1 and it goes to the 10, which is its peak point. So we can say the approximate amplitude is 10. Now for the time interval number 2, if we go time interval number 2, let's see what would be the possibility. Let me draw my shape again. Okay, it's been duplicated. So I am drawing for the time interval 2, and let's see what is the touching point of the line, and let me draw the circle so you may see its value. So you can see the line is being touched at the approximate sound amplitude 4. So we can say that at time interval 2 the approximate amplitude is 4. So you may easily see it. Let me just draw it more appropriate. So at the line number 4 of the sound amplitude, you may see that the time interval 2 and amplitude 4 is being intersect at the specific point. So this is how can we measure the time and all the graph values. So let's do a little exercise. I have already done it for you. Like let's suppose if I say that time interval is 3, so I'm going in the line of time interval 3, and what is the peak point which is touching it? So the sound amplitude is 9, because 9 and line number 3 is touching at the certain point, so we take it as a 9 sound amplitude. In the same way, if I talk about time interval 4, and time interval 4 is touching at the baseline, which is sound amplitude 0. In the same way, if I say time interval 5, then let's see time interval 5 is being touched at the line number 7. So our sound amplitude is 7. In the same way, line number 6, time interval 6, as you can see my mouse pointer, time interval 6 is being touched at the sound amplitude 8. Here you can see sound amplitude 8. So in the same way, if I talk about time interval 7, so it is being touched at the sound amplitude 1. As you can see the line of sound amplitude here. Now let's check for the time interval 8. Time interval 8 is touched here, and let's see this line goes at which position. Its sound amplitude is 2. In the same way, if I go time interval 9, then let's stop it here because the line is being touched here, and let's see where this line goes. It goes sound amplitude 5. So this is the way that we can point out the graph values using time interval and the sound amplitude. Once you understand this concept, let's study the time interval. Like let's suppose our time interval is 4, then we can say our amplitude is 0. And if I say our time interval is 5 and our sound amplitude is 7. Let's go for the next time interval. Let's consider it 8. Let's see time interval 8. Then our sound amplitude is 2. Now again, let's consider time interval 9. So time interval 9 is being touched at sound amplitude 5. So we type here 5. This is how we can recognize our graph. These are the sample values that I have done for you. Alright, I'm not filling entire graph. Now let's see that how the system calculates it. It says that 4-bit binary can be used to represent each amplitude. Let's consider the amplitude that we have done here. We have taken 0, we have taken 7, 2 and 5 amplitude. So let's consider 7, 2 and 5 amplitude. 7, 2 and 5 amplitude. This is the 7 amplitude, 5 amplitude, and wait, let me check. 7, 2. Okay. After 7 there is amplitude 2 and last amplitude is a 5. These are the sample values. Let's suppose we convert it into the 4-bit binary. So 0, 2, no, we take it 1, 2, 4, 8. So this is how we can convert our 4-bit binary according to the 1, 2, 4, 8 formula. So 4 plus 2, 6 plus 1, 7. In the same way we write here 2. So this is a binary value for the 2, and this is a binary value of 5. So this is how we can convert our amplitude into the 4-bit binary. I hope you understood. If you do not understand, you may text message me on the WhatsApp and I will explain you furthermore. So these are the sample test values that I have done it for you. Alright, now let's see next topic. Alright, so as you can see that we have seen the graph, like this graph. Its range is from 0 till 20, right? 0 till 20. So if we increase the time interval of it, like 0 till 127, then we will receive more digital data. So the point that we see here in the paragraph, let me interpret for you, that increasing the number of possible values to represent sound amplitude also increase the accuracy. Means if you that you have seen that our graph is start from 0 and finish at 20 or 21. But what if we increase the time duration from 0 till 127 and the sound amplitude from 0 till 20 or 30, then we will get more data. So if we get more data, our storage will be increased and the sound quality could be increased. So it says it gives a much more accurate representation of the sound sample. This is how they explain. Next is a sampling resolution. How does it happen? The number of bits per sample means in one sample how many number of bits do we get. In one sample how many number of bits do we get. It is called sampling resolution. We can also call it a bit depth. So in one sample how many bits are there? For example 4 bit, for example 8 bit, for example 12 bit. Whatever the number of bits we get in one sample, it is called sampling resolution or bit depth. In the same way, what is the sampling rate? It is the number of sound samples taken per second. In 1 second, how many sound samples do I get? In 1 second, how many sound samples do I get? The measurement is called the sampling rate and the unit is called the hertz. So we can say 1 hertz means 1 sample per second. Let me more justify it for you. Let's suppose if we talk about the sampling resolution. One sample, for example, the formula would be like this. Number of bits is called sampling resolution. This is the formula that you can understand easily, I guess. Sampling resolution, the formula is one sample. How many number of bits in one sample? Let's suppose if we get 4 number of bits or 8 number of bits or 12 number of bits in one sample, then we can say that it is a sampling resolution. In the same way, sampling rate. Sampling rate, what is it? Let's see. It says number of sound sample taken per second. It means 1 second. How many get number of sound samples? Number of sound samples. So how can we understand this formula? Sampling rate, what is the sampling rate? That in 1 second how many number of sound samples do we get? In 1 second how many in 1 second, let me drive it more detail. In 1 second how many number of sound samples do we get? It is called sampling rate. And in one sample how many number of bits do we get? So this is the easiest way, I guess, according to my opinion. I think it is easy to understand for you. So sampling resolution, in one sample how many number of bits, and sampling rate says that in 1 second how many number of sound samples do we get. This is the explanation. And next point is, how is sampling used to record a sound clip? Means if I want to record my sound clip, so how the sound sample is being used or utilized. So there are the key factors such as, let me highlight for you. Okay, the amplitude of the sound wave is first determined at the set time interval. So it means that the amplitude of the sound wave, like according to the sound amplitude formula, wave is first determined as a set time interval, means the sampling rate, that we must measure or we must monitor the sound amplitude and the wave is first. So first set both of the values, and it says that the time interval they are referring to the sampling rate. Okay, we have already understand that in 1 second how many number of sound samples are there. So we have to first determine amplitude along with the time interval. So in 1 second how many number of sound samples can we take? This is the process that initializes. Next, the key factor is, let me highlight it for you again. Okay, this gives an approximate representation of the sound wave. Because there is no fixed value, so it will give an approximate sound representation of the sound wave. Third key factor, let me highlight it for you. It says each sample of the sound wave is then encoded as a series of binary digits. Like when it finish gathering the data, then it goes for the process of encoding, and in the encoding it creates a binary digits, so the computer can understand how to process this data. This is a paragraph like let me highlight for you. Using a higher sampling rate or larger resolution. I already explained you this point that higher sampling rate or higher resolution will increase the storage capacity, or it will give you a more detailed sound source. So it affects your sound quality as well. Let's discuss the benefits and drawbacks. Larger dynamic range, of course, more detailed sound gives you multiple recognition, helps you to recognize multiple sound effects. Like if it has got larger dynamic range, so you can easily diagnose that which sound is this, or what are the musical instruments, if you are aware of the musical instruments. But drawback is produces a larger file size. Alright, now next is the benefit, sound quality, but it takes time to download or upload the music files. Next benefit, less sound distortion, but the drawback is require greater processing power, because if you want to edit your sound, edit your background sounds, edit your noise level, so it will just less it, but it will require more processing power, because it will take more time to edit or render your audio file or the video file. So these are the drawbacks and benefit. I hope you understood, but if you do not understand, you may text me on the WhatsApp. Last key point of the sound representation, let me highlight for you for the better understanding. CDs have a 16-bit sampling resolution. CDs have got 16-bit sampling resolution and 44.1 kilohertz sampling rate. If we convert kilohertz into the hertz, then we get 44,100 hertz, and we can say that for 4,100 hertz are the samples that we take every second. What it affects? It gives us the high quality sound reproduction, but greater the file size. So this is the end of the topic of the sound representation. If you do not understand, you may WhatsApp me. I have shared my number on my channel, so you may contact me there. And if you have understood it, then it means that I have accomplished my mission. And thank you so much for watching the video and understanding the topic. And I will upload more topics videos along with the explanations. If you need the transcript of this video, or if you need my notes that I have explained with the reference, so I will give you a link in the description, and you may download these notes, so it will be feasible for you to understand it. Thank you so much. Allah Hafiz.